Okay, so what you're looking at here is like two different problems. So just keep your eyes peeled focused on the top of the page at first. Like the top of this page, I just gave you two triangles. They're all marked up. All the congruent parts are marked up. And then I gave you a congruence statement. That's one of the things that you need to understand from today's lesson is what is a congruent statement. A congruent statement is, in this case, it says triangle ABC is congruent to triangle TRS. That is the congruent statement. All right, I want you to stack it. And whenever I say stack it, I'm trying to teach you this concept today. This is a trick that I've used to help organize this entire concept very, very quickly and efficiently. Here's how I do it. Here's what stacking means. I'm going to take A, B, C. When they give it to me horizontally, I'm going to write it vertically. I'm going to put T right underneath A, and R right underneath B, and S right underneath C. So when they give me the statement horizontally, which is the way our book will give it to you, they're never going to stack it. I'm going to stack it because this helps me, I think, more than this. And the reason I think that's true is because it tells me all the parts that are congruent. And if you refer back up to this original two triangles, notice how they're all marked up. Like they're not always going to be marked up. If they give me this congruent statement, then all the markings would be true, but they won't always be marked. Okay, so you know, if I have one arc on angle A and there's one arc on angle T, that means congruent. 2, 2, 3, 3, so on and so on. The sides have the slash. Y'all familiar with the markings, right? So stacking tells me all of that is true by looking only, if I just look only at the stack, if I only look at this thing without any vision of the triangle, I don't even know what the triangles look like, then I can look at the stack and I can say, oh, if these are congruent, then angle S must be congruent to angle what? C, and because it's right on top of it. Do you understand stacking? So angle B must be congruent to angle R. Okay, side AB must be the same as side what? BC is the same as RS. AC is the same as TS. Okay, and so you'll see this the way that I marked that up. Once you know how to stack, you don't have to mark all that I just marked, but it tells you a lot of stuff. The first questions they ask when they come up to congruent triangles is, what's true if two triangles are congruent? Well, there's a whole lot of things that are true. There's 3 pairs of sides that are congruent, and there's 3 sets of angles that are congruent. Right, and so I've listed them all here. All the information is given, and this is, you know, we just got through saying over here, if C has to be congruent to S, and if you look down here, it's marked C and S. So all this information is given in the stack. Okay, do y'all see how that works, how the stacking works? Anybody got a question on stacking, what's going on so far? I know this is new and weird at first, but after a while you'll appreciate stacking because it makes this really easy. All right, so down on the bottom, let's go ahead and look at the bottom part of this. This is for notes, for you to kind of understand the lesson for the day. I gave you 2 more triangles, and I gave you a congruent statement. All I did was give you a picture, and I gave you a congruent statement. So I want you to go ahead and stack it. So on this hole down here where the highlighting is, go ahead and stack it. That's the first thing I would do with this. I would say A, B, C. I don't know why I wrote A right there. A, B, C is congruent to D, E, F. And I'm connecting these. What I do is the angles between the two, I match those between them and the sides on the outer parts in terms of listing all the ones that are congruent. And so then from there, I want you to mark all the congruent parts appropriately, and I want you to list all of the congruent sides. So I'm going to start by listing the congruent sides. I'm going to fill in the highlight. So according to my stack, AB is congruent to what? DE, right? It's easiest, I think, to look at the stack than it is to look at the triangles. I don't know if you're aware of this, but the problem is the triangles have been misoriented. It would be easy if they were laying in the same direction, right? But they're not. They're turned around, and that's why they're confusing. All right, so BC is congruent to EF, and then AC has to be congruent to DF. Okay, y'all see where I'm getting all that? You guys are okay with that? Okay, so go ahead and fill out the rest of these. Angle A has to be the same as angle D. Angle B has to be the same as angle E. Angle C has to be the same as angle F. All right, now, once I've listed all this, this becomes really easy to mark. So let's start with A. We'll mark a single arc on A, which means we're going to go to the other triangle and mark a single arc on B, because those are the two congruent angles. Those are the two that correspond is the word that we want to use. Jack? Okay, so Jack's question is if they went CBA, could we still make a statement that would work? And the answer to that question is, if CBA, then I would have to write FED, right? Well, if our book gives you, if they give you a statement, then they're sure. I mean, yeah, they're going to give you the corresponding angles that do actually that are. So if they give you the statement without any information at all, like I have here, then the given information is what tells you what's congruent. And so, yeah, they don't have to be in alphabetical order or anything like that. It could be anything. It could be MPT, AXM. You know, it won't matter, just as long as. But what matters is this word corresponding. When I say corresponding parts, that means that one from one triangle that matches one with the other, those have to. Does order matter? Is the question. You know, does order matter? Like. So what I said here, CBA would be, in this case, FED. If I wanted to say BCA, then I could say EFD. But my point is, we can go ahead and answer this question over here. Does order matter in the congruent statement or the stack? Does the order matter, y'all? It 100% does matter. Don't pick no. It absolutely matters, okay? Because what we're saying here is that angle A corresponds to angle D, and angle B corresponds to angle R, which basically just means that it's in the same place, regardless of the way they turned it around. Are you with me? So they're trying to hide it from you, but I'm trying to help you not be tricked by their misorientation. All right, so let's go ahead and fill out the rest of the markings on this one, which should be pretty easy. If I put 2 arcs on B, then where would I go with the other triangle to put 2 arcs? You got to go to E, which means that you would use 3 arcs on C and then 3 arcs on F. Let me ask you this. Had I wanted to put 1 arc on C and 1 arc on F and 3 on A and 3 on D, would that be okay? 100% okay. It doesn't matter. These just say they're congruent. That there's 3 different congruent pairs of angles here. It doesn't say, doesn't matter which one has 1 or 2 or 3. All right, and so go ahead and mark your sides. So AB is congruent to DE, and then BC is congruent to EF, and then AC is congruent to DF. So each one we have in the same diagram that's a different congruence statement, then you would add a notch or an arc, and that's the way congruent triangles will work.